students, I am your Komali Mam. In this session, I am going to teach you the confusing topic that is called types of solvents from organic chemistry. See, what is a solvent? What are the types of solvents like polar, non-polar, and what is a polar protic solvents? What are polar aprotic solvents? And I am going to teach you the difference, how to identify in a just seconds. Okay, watch this video up to the end, then you feel very easy to identify different types of solvents, which helps you so much in doing substitution reactions, right? Nucleophilicity, when you are doing substitution reactions, this will help you. Polar protic solvents and polar aprotic solvents. Let's begin the session. What is a solvent? See, solvent is a type of solvent is a substance which is helpful to dissolve some other substance. For example, we are doing one organic reaction. Organic compounds are solids. If organic compound is a solid, to do the reaction, first we have to dissolve that organic compound in a solvent and to make a solution. So, solvent is the substance. Solvent is the substance which is used to dissolve some other substance in it so that it forms a solution. This solution is ready so that we can do the further reaction. Solvents are how many types? Solvents are of two types. What are those two types of solvents? Types of solvents. Types of solvents. There are two types of solvents. What are these two types? One is polar solvents. Another one is non-polar solvents. What is that, students? Tell me. Polar solvents and non-polar solvents. What do you mean by polar solvents? Non-polar solvents, these are the solvents, there is no electronegativity difference. For example, you take benzene. Here also carbon, here also carbon. Same atom, no electronegativity difference. You take, butane. Here also carbon, here also carbon, no electronegativity difference. Like between two atoms, if there is no electronegativity difference, then we call those solvents as non-polar solvents. Fine. And the compounds in which the dipole moment is zero, like CCl4, carbon disulfide, these are the compounds where dipole moment is zero. Those are also non-polar, like heptane, petrol, etc. These are the solvents in which there is no electronegativity difference. What are polar solvents? The solvents in which there is electronegativity difference and the dipole moment is, there is some dipole moment is not equal to zero, then those solvents are polar solvents. Okay, let us see the types of polar solvents. Polar solvents of two types. One is polar protic solvents, polar aprotic solvents. What are these polar protic solvents? Let us see. See, polar solvents, two types. Polar solvents, two types. What are those, students? Tell me. Polar protic solvents. One more is polar aprotic solvents. Aprotic solvents. Then you should identify in exam, very important, which is polar protic solvent and which is polar aprotic solvent. See the examples one time. Water alcohol, phenol, ammonia, amines, acid, HF, RSH, thiols, phosphoric acid, sulfuric acid, all these are polar protic solvents. See, polar aprotic solvents, these are polar aprotic solvents. Okay. Then how to identify in examination? Many examples are there, no? How can you identify now? I am going to tell you small trick. Just by using this trick, you can solve question very easily. Trick is where actually polar protic solvents, these are the solvents which gives H plus ions and which has the ability to form hydrogen bonding. These are called as polar protic. And what are polar aprotic? This cannot give H plus ions, cannot give H plus ions, and they can't form hydrogen bonding, H bonding. Okay ma'am, fine. How can I identify whether it gives H plus or not? Very easy. The technique is just you see hydrogen connected with either oxygen, nitrogen, oxygen or fluorine. Again I am repeating. Hydrogen connected with atomic number 7 nitrogen, 8 oxygen, 9 fluorine. Same sequence. Nitrogen, oxygen, fluorine in the same family of oxygen, even sulfur. This hydrogen is acidic hydrogen, that's it. See how easily you can do. Hydrogen connected with oxygen, polar protic. Hydrogen connected with oxygen, polar protic. Hydrogen connected with oxygen, acidic hydrogen, polar protic. Hydrogen connected with nitrogen, polar protic. Tell me next one, polar protic or not? Yes, this hydrogen connected with nitrogen, this hydrogen connected with nitrogen, this hydrogen connected with oxygen, this hydrogen connected with a fluorine, this hydrogen connected with a sulfur, phosphoric acid, this is the structure. So this hydrogen connected with oxygen, sulfuric acid, see the structure students, sulfuric acid, this hydrogen connected with oxygen, that's it. These are polar protic solvents, they give H plus ions. See the next one, acetone, CH3, C double bond, CH3. See this oxygen electronegativity is 3.5, carbon is 2.5, electronegativity difference is there. But there is no hydrogen to liberate. So it is a polar aprotic. In acetone, what you do is this carbon place put a sulfur. Acetone structure is easy. We can remember CH3, C double bond or CH3. That carbon place put a sulfur. Then what we will be getting? 2 methyl groups, dimethyl sulfoxide, DMSO, dimethyl sulfoxide. Next, see this is formic acid. Remove this OH with NH2. Then it is formamide. Remove these 2 hydrogens with 2 CH3 groups. Then it is 2 methyl groups are there, dimethyl formamide. See, DMF means dimethyl formamide. Next, dimethyl, this is acetamide. DMA. DMF is dimethyl formamide. DMA is dimethyl acetamide. This is tetrahydrofuran. In all this you can see oxygen is there, not connected to hydrogen. Not connected, that acidic hydrogen is not there, not connected to sulfur, not connected to nitrogen, not connected to fluorine. If this is there, polar protic, this is polar aprotic. Clear? In that way you can easily identify the type of solvents. Now very important one tip I want to give you all, how this polar protic solvents and polar aprotic solvents affects the nucleophilicity. Okay, nucleophilicity, how they affect? Effects of what? Polar protic solvents and polar aprotic solvents in nucleophilicity. Nucleophilicity. Listen carefully because students feel difficulty in this topic to understand. But by the end of this video, you say, ma'am, very easily I can solve the question. That is, what are polar protic solvents which can furnish H plus ions? For example, you take F minus, Cl minus, Br minus, I minus. This is what? NaF if you put in solvent, NaI if you put in solvent, then see NaF you are taking, okay, NaF, NaCl, NaBr and Na, correct. If you put in solvent, what will happen? Which one acts as a strong nucleophile or which one is a weak nucleophile you want to find. This is what? F minus na? NaF, see NaF we are taking, Na plus F minus, okay. This one, what will happen? It will break into Na plus F minus, okay, Na plus F minus. This Na plus is surrounded by the solvent. In the same way, this is surrounded by solvent, okay, solvent. This F minus, little I move this side. This F minus also surrounded by solvent, same solvent, same color actually, say white color also. I want to show you white color, okay. Solvent. But in solvent, if you take for example water is having which a charge? Oxygen is having negative, hydrogen is having positive, because electronegativity of oxygen is 3.5, hydrogen is 2.1. Oxygen is more electronegative, it withdraws the electrons towards itself, right? Now, what I want to say is this water, Na plus is positive charge, this oxygen is negative charge. This negative charge goes and do hydration to this Na plus. So negative charge comes this side, positive charge goes away. Negative charge, positive charge, negative, positive, negative, positive. Like that full hydration happens. In this case, this anion is surrounded by positive charge, like water which is having positive charges comes this side, negative charge goes out. Positive charge, negative, 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 positive charge. In such a way hydration happens. This is small, fluorine is small size. Top to bottom, fluorine, chlorine, bromine, iodine, top to bottom, size increases. Size increases, this iodide ion is a bigger size. This is surrounded by less number of water molecules. Water. Color I am changing na. 1 second. Water. All water molecules surrounds. Small size. Size is small. Hydration is more. Here large size of anion. Large size. Hydration is less. If hydration is less, what happens, students? Hydration is less. Then it attacks, it goes in, this is actually large size, but it was attacked by less number of water molecules. Large size, hydration is less, so it moves faster. Good nucleophile, nucleophilicity increases, it goes and attack. But in this case, small size, actually fluorine should go and attack faster, but because of more hydration, fluorine becomes weak. So what I want to say is, in polar protic solvents, I minus, Cl minus, Br minus, Cl minus, F minus, this is the order. Why F? Actually F minus should go and attack faster. But which is going and attacking faster? I minus. Why? Hydration is more in the case of F minus due to small size. This point is clear. Now, let us see what will happen in polar aprotic solvents. Polar aprotic solvents. Listen carefully. Little the twist if you understand. Done. This sulfur and oxygen is there, right? This oxygen is more electronegative than the sulfur. So, oxygen gets a negative charge, sulfur gets a positive charge. Due to this groups which is around the sulfur, this positive charge is less accessibility, less accessible. S plus is less accessible. This O minus is more accessible, more accessible. Due to this reason, when you put Na plus and F minus or Na plus I minus, this negative charge should attack by this positive ions, right? During hydration, but this is not that much accessible. So this S plus can't come and do hydrolysis of this F minus or I minus, Cl minus. Only this positively charged Na plus is surrounded by this oxygen of this dimethyl sulfoxide, DMSO. See, this oxygen comes here, sulfur 2-methyl groups like this. That attack takes place in such a way. So, simple point I want to tell you, polar protic solvents, both cation and anion undergo, surrounded by this solvent. But polar aprotic solvent, only cation will be surrounded by this. Or still more simpler way I want to tell you. Easy technique. This much time you listen the class, right? One and only one point I say. You can delete all this concept from your mind. Based on one point you can solve the question. That is, if the size is bigger, that is a better nucleophile in polar protic solvents. If size is smaller, that is a better nucleophile in polar aprotic solvents. So, how easily you can do, students? You can delete all this from your mind. One and only one point, that is, tell me, polar protic solvents. Bigger size nucleophile. Bigger size means it is a good nucleophile. Polar aprotic solvent, small size, it is a good nucleophile. That's it. Shall we start solving questions? Will you answer? Let us see. I'll give you questions. Try nitrogen. Next element is oxygen. Next element fluorine. Okay. Nitrogen next element is phosphorus. Oxygen next element is sulfur. Fluorine next element is chlorine. What I do is just I'll make NH3, PH3, OH minus, SH minus, F minus, Cl minus. See, like this I am framing a question. Ammonia and PH3. Top to bottom, what happens to the size? Top to bottom, size increases. So, in this two, which is a bigger size? PH3. So, polar protic solvent is given. Then PH3 is a good nucleophile than the ammonia. In this two, oxygen, sulfur, which is bigger size? Sulfur. In this two, which is bigger size? Chlorine is a bigger size. So, this is about polar protic solvent. Can you tell me polar aprotic solvent? Polar aprotic solvent, small size. Polar protic solvent, large size. That's it. This one single point you solve the question. Nitrogen, phosphorus. Nitrogen is small size. Over. Next one, Oxygen, sulfur, which is a small size, oxygen. Fluorine, chlorine, which is a small size, fluorine. Easy, easy, that's it. Which are connected with, when there is electronegativity difference, polar solvents. No electronegativity difference, polar aprotic solvents. No electronegativity difference, non-polar solvents. Polar solvents two types, polar protic, polar aprotic. Polar protic means which can furnish H plus ions. What are the examples? Hydrogen connected with oxygen, nitrogen and fluorine or sulfur, they can give H plus. Or polar aprotic means electronegativity difference will be there but they can't give H plus ion, like dimethyl sulfoxide, dimethyl formamide, dimethyl acetamide. Okay, clear everyone? Clear? Now I'll give you test yourself question. Take out this screenshot of this. Take screenshot and note it down in your book. Find it out. Acetic acid, ester, water, alcohol, acetone, ketone, and dimethyl sulfoxide, ether, benzene, dimethyl formamide, dimethyl acetamide, methyl formate, okay, ester. These all examples, which category, you just try it. In the next video, I'll give you the solution. If you want like this more number of videos, just subscribe to Komali Mam channel. Click there, one bell symbol will be there. Please click on the bell symbol so that you get more videos from me. If I upload, whatever the time I upload, you get immediately notification. And click on a like so that if I get more likes, then that gives me a satisfaction and it inspires me to do more and more videos for you. And you just message me how is the video and what type of content you are looking for. If you message me in comment section, that becomes very easy for me to upload more videos for you. And those who are looking for the best chemistry courses to complete the entire syllabus in a short duration, even I am taking online classes too. Satisfaction rate is very high for the online classes. You can even choose me as your chemistry mentor so that you can become excel in your chemistry. Thank you so much for watching this video. See you again in another video. Bye, love you. Have a nice day.